remember to save your class attendance. And notice the button is now gray. So everything's getting a little bit better. I didn't like green, it's now gray. So there you go. It matches the other grays now. Zip file. All right, let's get going. So, today we're going to be diving into something called functions. Functions are a way we can increase the dryness of our code, make our code less repetitive, and they're a very important part of Python programming and programming languages in general. They're one of the most fundamental concepts in computer programming, and we're going to be going over those today. So who here has been using Git for their homework too? Some. Yeah, everybody has been, no doubt, enjoying that. So has it been pretty much happy, frustration-free experience using Git? Why are people shaking their heads? I don't know. Or is it maybe a little bit more like this? I don't know. So just as a reminder, Git is hard. Git is really easy to mess up and hard to get to do what you want it to do very often. And just as a reminder, accept that this frustration is part of learning these concepts. So if you find it frustrated, that means you're probably doing something right, because you're pushing your limit, your knowledge in this area. And it will not go away. It'll continue to be frustrating. Git never stops being frustrating. And kind of just a rule of thumb on Git in particular, I feel that if you're not really sure how to do something with Git and you feel like you've kind of gotten yourself in like a hole, like a dead end, create a new repo on GitHub and start again, copy over the files you want, and start from there. There's nothing preventing you from doing that. It'll probably take you less time than figuring out how do I mess up my Git repo or something. So whenever you feel like you're at a dead end, never be afraid just to start over again with that process and just copy over your files. You don't have to use any fancy commands to copy them over. Just drag and drop them over to your new repo. And keep the other one around just in case maybe you didn't copy everything. So just to make that transition. So that's something I recommend with Git in general. Don't be afraid to start over again if you feel like you got yourself in a hole. Don't be alone. Form a study group. I don't know if that anything came of this, but I do know that in the Study Lounge channel, there was some talk of forming a study group. Anyone here interested in forming a study group or meeting with people out of class? Cool. Yeah. So have you guys been doing that at all, or? Yeah, haven't had time. Okay, cool. I mean, that's understandable. But there are clearly people who are interested. I mean, you all are studying the same thing, so that's always, just a nudge here. Good idea. Maybe follow up on this idea. It's not the worst idea in the world. Yeah.
What do you study groups do?
Great. Okay. Great question. Whatever they want to do. I mean, you'll be the masters of your own study group. So they could, for example, just work on homework silently together. I don't know, and then just bug each other when you get stuck, or maybe they could just go over see if anyone else in the group understands something that one person didn't understand. You go into it and you're like, I just don't get why there's a while loop here. And maybe someone else knows it, or maybe they don't, and you can talk about it. So it's kind of up to you what you want it to be, but it could be any of those things. Great question. And then finally, step 3, fight imposter syndrome. Anyone maybe at one point in programming think, I can't be a programmer? Have that feeling ever? Yeah. So that's not going to go away, and it's going to stay there, and you have to keep that keep that in mind that you're going to have those doubts. So redoing class activities outside of the class. Anyone doing that? Going back to the activities, redoing them outside of class. Cool. Yeah. Most people are doing that. That's a really good way to study and reinforce stuff. And then when you need more help, come to our study lounges. There's one tomorrow, one after class on Saturday, and ask us on chat. Remember, you are learning 4 years in 4 months, something that maybe normally you'd gradually learn over a long period of time, all of these different tools. I learned HTML and CSS maybe 8 years or 7 years before I learned Git, right? So these are things that often people learn gradually over a long period of time. I learned HTML and CSS, and then several years later I started learning Python. Several years later I started learning Git, that sort of thing. Usually you let it kind of soak in for a really long time, but we're condensing this, which is why it is hard and frustrating, and your brain is getting inundated with so many new ways of thinking. Cool. Any questions about that before we get to our first activity? Sweet. So let's do that then. So the first activity is a Python review activity, and we're going to start by adding a print statement like our other activities. Do print. Like this, print doing activity. We do Python review. So always start with a print statement. Why do we always start with a print statement? There's a couple reasons. Someone help me out. Marlon?
See if your syntax actually works.
See if your syntax actually works. Yeah, that's a great reason. Because if there was some typo in here, then you would immediately get a mistake. You'd get an error, and that would help you know. What are the reasons? What common mistakes does this help prevent?
So you're working on the right file.
Know you're working on the right file. Yeah, that's a very common mistake. Oh, see, I accidentally added a. Whew.
That cutting board almost didn't.
Yeah, that would have been the end of this class. I think would have just been. That's how it would have ended. All right. Right. Make sure you're editing the right file. In that case, actually, it was helpful because I accidentally just had a space there. I just introduced it, and if I had not run it right away, I would have not noticed that I'd made a typo. Literally, the first thing I did, I accidentally added some space there. Cool. So, activity 1, Python review. Oh, this is a heavy-duty thing. That I have no idea what to do. So I don't know if help is the right word. Just any ideas? Maybe that's it.
What is that one? CME2?
I don't know. I don't remember. This one's so heavy. It has to be on. What's up? Some scotch tape, I think. Yeah.
You want me to grab it?
Sure, if you want to get on that round. Give that a go. I have a question, not sure where to start. Let's see.
Still starting.
Okay. Know how to start? We encourage your words. That's all. Imagine you're being encouraged. Yep. Just to call it.
What we do all for captain.
Use space. What was that?
What we do for
Yeah. You may have to take, yeah, one check to see. Yeah, not like rolling just yet. You'll still have to write the rest of the day. I'm just cheating. It's okay. You gotta be quiet. Less. Just to be clear, you know, just less.
Oh, yeah, okay, cool.
Just double check. That's fine if you don't make noise. In. So it's not a method, it's while you, it's like in dick. So while user input or if okay. It's one way you can do it, but a better way would be if user in
Just like the one that I did.
Exactly.
On my
Does that make sense?
Yeah, yeah.
Okay. Cool. If it's in a drawer, that'll probably be helpful. You can be wooden source. Unless it ran off somewhere, which is always possible. Actually, hold on. Oh, there's some scotch tape here. We also have some binder clips.
Huh. I'll
Um,
go take this back.
I don't know if scotch tape is really even going to be enough though, but maybe the binder clips will do something here. Sorry. There we go. Binder clips.
Yeah. Stuff, but
Okay.
we'll try to figure it out.
Okay. Which one do you want?
Sad, this one stuff.
So you're kind of looking at your previous ones for hints.
Yes, sir.
Okay. I might be going over. See, which one you got? Okay. You can't have spaces in your variable names. No spaces ever again for you.
Really? So like it has to be right only. I thought we
No,
wanted
no, no. Spaces in your see your name.
I see what you did there.
See what I mean? See.
Okay, I'm trying to keep us on our toes.
Yep.
Got it.
Does that make sense?
Yes, sir. Thank you. Space.
Yep. Same places. You can't have spaces in your variable names. So your name has to be your underscore name. Does that make sense? Just get rid of spaces if you have in that one. There's no space.
Did it actually? Oh, it did. Yeah. Two. Yeah. Totally. Oh boy, I guess.
There's two ways. One way is you can go backslash the other way on the other one. Yeah, that's one way. The other way is you can do double quotes instead of single quotes on the outside.
Yeah.
Well, no, you'd have to do double quotes all across the board. Does that make sense? But backslash also. Questions? I heard of them. So. Yeah. Okay.
Yes, sure. So it looks like it will go until here, but I'm not sure that it is, but I'm not getting this question on the screen that I'm expecting.
Okay, well, it's actually an infinite loop.
Okay.
So if you get stuck there,
Right.
all the length of that is zero. Will the length ever change?
Okay.
The length never changes, so it's stuck there. Does that make sense?
Yeah, so this wouldn't say while the length is zero, set it to equal one instead.
No. And you never can set it equal to one because that's the length of the list. You have to add stuff to make it longer.
I see.
Like, that makes sense?
Yeah.
So yeah, that does not do that. For one, it's double equals is comparison, not assignment. That's one issue. Remember, single equals is assignment, double equals is comparison. That won't work either because you cannot assign it'll
Yeah,
order,
I
actually.
have to store it.
That's probably where you started. Yeah, that's probably where you started with,
Okay.
and then you added double equals. So
Yeah.
that code will do anything you
Yeah.
want to do. But I guess you have to think about what you want to do. Why would you want to make the length of the list one?
Because I'm trying to divide the length. I'm trying to divide the sum of the list by the length of the list to get the average.
Well, the length will never be. So the length will start out at zero because there's nothing in it, and will always be zero until the next.
So this would never work. I would have to store a variable for the length so that I can manipulate it.
Perhaps, but I think you want to think back. I think you want to take a step back and think maybe that's not what you want to do. Is change the length. You want to add stuff to the list, not change the length. Adding stuff to the list will automatically change the length of the list.
So I guess that's what I tried to do initially,
Yeah.
but then I got a divide by zero error, and I thought it was like because of an order operations.
I mean, I think, yeah. Maybe pseudocode your stuff a bit deeper is my advice, actually. that's an interesting thing.
Yeah. Good. Hopefully good. Just got challenged to. One was good. Two. I don't know how to test it. I think it's okay.
Okay, well, test it. Okay. Big tip when working with Python. One change at a time, always test it.
Okay.
Do not, if there's an issue, solve it right away. Otherwise, you're going to get way far ahead of yourself, and you don't know what's constantly there.
Yes.
So save it and see what happens. So there's no errors. That's a good. That's like no news is good news. The second thing you want to do, if you want, you can try to print authors list just to see if that.
Just to test.
Just to test it.
Yep.
I'm going to be going over the first few couple challenges now. So the first one is create 3 variables, store them storing them your name, your favorite color, and how many hours of sleep you got last night. So we can't just do your name like this. Why can't we do that?
There needs to be the space.
The space, yeah, we can't have spaces in variable names. Python does not allow that. We can do an underscore, that's fine, but no lack of, you can't just have a space there. So your name, Jane, I'll just do it for me, Michael, your favorite color. Fave color equals green. And then how many hours of sleep last night? I don't know. I got like a good solid like 8 or something. It's nice being able to sleep in, that's for sure. So, not gonna lie that I think I got a decent amount of sleep. So now we want to print out all 3 values. There's a few ways we can do this, but we could do something like your name, print fave color, print hours of sleep. There's one way we could do it. We could also add maybe like a little bit of a, name, just so we know what's going out to our screen. Favorite color, and then sleep hours, something like that. So then challenge 2 is create a list of your favorite book authors, put them in a variable called authors list. So we do something like this, because thing on the right goes into thing on the left. In this case, the thing on the right is a list, and then we can start adding some authors. What are some favorite book authors? Anyone?
Tim Ferriss.
Hmm?
Tim Ferriss.
Tim Ferriss.
Tim Ferriss, okay. Tim Ferriss, is this how you spell his name?
Yeah.
Yeah.
Cool. Any other ones?
R.
George R. R. Martin, yeah. Yeah. Dr. Seuss, that's a classic. Nice. Warren Buffett? Okay. Yeah. Right. Let's see. R.L. Stein. Got all sorts of. Yeah. So then that's an example. We have a bunch of different authors, and you can write an if statement to see if the top one is equal to Douglas Adams. If it is, print don't panic. Otherwise, print panic. So if authors list. So yeah, I'm going to go ahead and do challenge 3, which is if. So it's write an if statement. So if statements let us branch code. So if authors list equals authors list 0. Why is it 0 to get the top author? The first one starts at 0 because computers start counting at 0. So Tim Ferriss is 0, not 1, which is what you might think. So if it equals Douglas Adams, print don't panic. Notice that I use double quotes here because otherwise the single quote will end the string right there. We want to use double quotes so that it doesn't end the string right away because if I did single quotes, Python won't be able to distinguish. Look what the syntax highlighting is showing. Python won't be able to distinguish between the apostrophe and my quote. So it thinks my string is ending after Don. Print panic. let's give that a shot. So it's going to say panic because the 0th one is not Douglas Adams. And let's work a little bit more on challenge 4, and then I'll be going over that, and we'll go on to new content for today. Yeah, what's up?
So what if author is not on the first index? I mean, on challenge 3.
Mm-hmm.
What if it's on like the second index?
If you wanted the next one, it would be like this.
So can you just also say if Douglas Adam in author list?
You could do that too. But that's not that's checking if it's anywhere in it. So if you did if Douglas Adams in author list, so what this will do is see if Douglas Adams is anywhere in the list, no matter where the location is. But we're trying to check if the top author, if it's the top author, then we do 0. Does that make sense? Cool. Great question.
If I want to check for something in the just like spaces,
That's short.
so lower the input, right?
Make it lowercase.
Make it lowercase and compare with what's in the dictionary. Check the basketball.
Oh, you're putting a space in it. So lowercasing it doesn't remove spaces.
No space. No.
Volleyball, golfball, basketball. Oh. Oh, it's because, so let me explain what this is doing. The if user input dot lower doesn't permanently lower the lowercase does. It'll only do it here, but then it'll be still uppercase there. Does that make sense?
Gotta do it in input.
Yeah.
Makes sense.
Yep, or you could do it in both places. You know.
Is there a method for like moving white space?
Yeah, there's a few different ways to do that. One is dot replace, and then parentheses, you can put in quotes a space, and add another quote,
Yeah.
comma, and then put in 2 quotes right next to each other. So it's replace all spaces
Spaces with nothing.
with nothing. Does that make sense?
Yeah.
That'll replace all spaces.
Like a
that.
chain of them.
Yeah.
Is there any other method that you can replace with the first element in the relation like first?
Cool. This is the only one.
Is there any good
One
one?
way to do it is the right way.
It's just because like the reverse
No, there's nothing like that. If you want to do last, you do negative 1. So, I mean, I think that kind of that goes into why there's a big philosophical problem here. mess it up, it'll be part of the name and it'll be like say colon. Yeah, so it's probably not what you want.
Okay, so it's going starting with the pressure, and it's less than at the end of it, so it's like it's the
That's short.
and what's it canceling out exactly? Okay, thank you.
That should work. Let's see. It is a little bit different actually, though, and it's not correct, because I'll tell you what the difference is. Why it's usually not correct. But I think it will happen to work in this case. At least I think it should. But is not. What it does is it compares. So equals compares if they seem the same. Is not compares if it's exactly the same thing.
It's like more specific.
It's more specific. It's more like okay, we have two lists and they have the same elements in them, then the equals will compare them as being truly as equal to each other. So you can do double equals to make sure the two lists are the same. But is not, we'll see if it's actually the same list.
Also the order.
Yeah, so the double equals will check the order and the comments in them. Is not, we'll see if you're actually comparing the same list to itself. Does that make sense? We don't actually even talk too much about is not, because it's not exist. Is not.
Yeah.
Is it a different case in JavaScript?
Yes. JavaScript has no double equals. Python's double equals. JavaScript does not have. That's the key. Because JavaScript can't compare lists and objects. Python can. Everything is like is not. JavaScript's triple equals is the same as it's not. Python's double equals is more intelligent than that. Does that kind of make sense? And this should work, I think, because for primitive types like strings, is not. It's double equals. I think that's cool. So is none right? None is like none is for none because there's only one none value. So it'll always work. It should work with most primitive types actually. There's only one true and one false. But there could be more than one list with certain elements. Okay, so I'm going to be going over challenge 4 and 5 now. So uncomment the provided code. What does it do? What does this code do? Someone help me out. When you uncomment it and run it.
It just print out.
It prints out, so this code prints out the 0th author and the length of the author list. So there are 5 favorite authors, and Tim Ferriss is the 0th author. So then what we want to eventually do is make something that loops through the list, printing out every single element in the list. And oh dear. And we can do something like this. So we need to use these were clues of things that we need to do. So while I is less than length, so how do we make I count up to a number?
While I less than the length.
While I is less than the length, yep. And then I plus 1, yeah, we have to increment I every time. So then we can do I equals I plus 1 here. So then what this will do is let's work out what it'll do. When run, it'll print out all the different authors, but let's look precisely at what these are. Let's look at what the code will do. At line 67, it puts the value 0 inside the variable I. The value 0 inside the variable I. Line 68, we haven't really talked about this len thing, but that's short for length. And that will find the length of authors list and put it inside of the variable length. So it'll get the length, how long it is, how many elements are in it, and put it inside the variable length. That number will be an integer. It'll be 0, 1, 2, 3, 4, 5, whatever. We don't know how many. Actually, we do. It's 5, but it could be different. It could be a different length. So we'll put 5 inside of length. While I is less than length, is 0 less than 5? Yes. So because 0 is less than 5, because so length resolves to 5, I resolves to 0. So 0 is less than 5. It'll then print out authors list 0, which is the 0th element. So then that eventually evaluates to be Tim Ferriss, I think. And then I equals I plus 1, that'll make I equal to 1. So then it'll do, while 1 is less than 5. Is 1 less than 5? Yes. So then print authors list 1. It'll then go, because there was I there, so it'll do print authors list 1, then print authors list 2, then print authors list 3, then print authors list 4. And then once I gets to 5, is 5 less than 5? No, 5 is not less than 5, which means it'll end the while loop there and skip down to line 73. So it'll stop right then. Why do we want it to stop at 5? There are 5 elements in the array. Why do we want to stop at 5? This might be counterintuitive. We actually don't want it to do 5, number 5. We want to stop at 4. We want 4 to happen, but not 5. Because we start at 0, right. So it's actually 0, 1, 2, 3, 4. So that last one is actually 4, not 5, because we started at 0. Which means we want to make sure we stop at 5 when we're looping through it. Otherwise, we'll get an index error. Now we can do something here. Uncomment the following code. What does it do? It's going to ask the user for input while asking them stop. So we can try that out. Stop. Sure. And that's what, that's all it does. It just asks the user for some text. We want to keep on asking it until the user says stop. So we do while, one thing there's one way we can do this. We can do user, while user input does not equal stop, print, okay, I will keep asking. And then we put this inside of that loop too. Okay, if we did this, what could happen here? Infinite loop. The reason is because we don't have any way for user input to change while in that loop. Whenever you're thinking of a loop, always thinking about how do I make this loop stop? Because otherwise it'll be an infinite loop if it doesn't ever stop. So we can do something like this. Stop. No. Please don't stop. Thank you. Stop. Uh-oh. No. Stop. There we go. So then once I actually typed it correctly, it actually stopped then. So this time I had a capital T, so it wasn't the same because it compares case of characters. So it keeps on asking, and the way this works is this one will ask the user for input, put it inside the variable user input. Then this is essentially like an if statement. If the user input is not equal to stop, but because it's while, it'll keep on doing it. If it was just an if statement, it'll only do it once. While will keep on doing it. While the user input is not equal to stop, it'll then print, okay, I'll keep on asking, and then ask again for the user input. Questions about this? Yeah.
So you're repeating the input stop question
Mhm.
like twice. I put like user input on the top as none value.
Yeah, you could do that too. You could also do an empty string. Anything that isn't stop would work there. It's that's probably slightly better to do it something like that. But it's, yeah, a little bit repetitive the way we have it there. Great question. Any other questions? Yeah, Roman.
So I guess for the last user input, the indentation really matters.
Oh yeah, because if it was like this, then it's not in the while loop. While the while loop looks at what's in the indentation. If it's like this, it'll be an infinite loop. Like this, it'll actually ask them every single time before checking it again. Another thing to think, the last thing that's in your while loop will be the thing that happens before it checks again. Any other questions? Wentz.
The exclamation and the equal sign before stop is
Very good point. I don't think I've gone over this. So this is equals. Double equals is equality. It checks for equality. Exclamation equals is does not equal. So it's the opposite of equals. Another thing we could do is actually while not user input equals stop. That would do the same thing. But does exclamation point equals is how you do in code does not equal. The opposite of equaling. Yeah, Mikkel.
How do you ignore letter casing?
There's a couple ways to do this. One way is you can do dot lower. That'll make it lowercase, so then we can do something like this. So if the lowercase version of what they just inputted does not equal stop, So that's lowercase phi. Dot lower will make it lowercase, and then you check against it the lowercase version. Yeah, Michael.
So I tried that. The only issue is when I put the variable to equal none, it doesn't, it errors out. Is there a way around? I guess the way around is doing it.
You could this way, or we could just do something like this.
Okay.
So it's just an empty string, or just like start. You know, anything that isn't stop would actually work at that point.
Thank you.
Great question. All right, so I'm just gonna go to the solution and take a quick look. So we already went through these. How you can create variables, set them equal to things. Example of how you can create a list of authors, access the top one. In this case, we made the top one indeed Douglas Adams, which means this will print out "Don't Panic" because the top one was Douglas Adams. And then we have we loop through the list, printing it out. I realized along with its index, I didn't do that for the previous one. You can just print out the letter I too, so it'll be 0, 1, 2, 3. It'll actually number them this way. Yet another example here. This solution is actually using the none to begin with. So that none can just be a placeholder. If you don't know what you want to put in your variable later, you can put none in it as a placeholder for something later. Yeah.
In that case, actually, no, never mind.
Cool. And then here's an example of the other one, which is a little chat bot that basically uses this dictionary to reply different things depending on what they entered. So we can actually see this in action. It's kind of a fun little thing you can make. So stop, and then, whoop. I just made that mistake. Python 3, not Python. Python 3, not Python. Otherwise it'll come up with error is not defined. Stop. You said stop, and then we can do like hi, hello, how are you? I'm okay. ... Oh, it's a sad robot. And then we can like, are you a robot? Of course not. Are you a robot? No. Sure. Well, now I'm doubting myself. But that's kind of how this code works. How it works is it's kind of like this previous stop one, except it's using a dictionary to know what to reply with in the whatever it receives. It'll know something else to reply with. Yeah, Nicole.
In that solution where you have an and in the middle, would
And combines two conditions. So while answer is not goodbye and answer is not bye. So it's checking both. If it's either goodbye or bye, then that would work. Yeah.
Shouldn't be or?
yeah.
Or, it should not be or, because everything is either not goodbye or not. Like, we want to make sure, so or would be, okay.
It equals.
Yeah, because we want to check to see if it's not one of those two. Let's see. So if we try again, and
Oh, okay.
it's a weird, you have to kind of think about it
But
deeply.
if those were equals, then it would be or.
Right. So it's like, so stop, we can type in, goodbye, and it'll quit then actually. But if it was or, it would actually never start because then it's everything is always not one of those two. Or it'll always continue. You're right, because it'll always continue because goodbye is not bye, so it'll never end. Don't worry too much about that if your brain is in a giant knot of logic right now. Let's get on to the fun stuff. Functions. It's so fun. It has fun right in the name. Can't spell functions without fun. So yeah, that's why they call it functions. Let's look at what a function is, why we want one, and what we'll be using for the rest of the day. So a function has a few different key things about it. The thing we're going to worry about right now is these top two things. Notice it starts with def. This is what a function looks like. It starts with def and then has a name. Notice the name has underscores, does not have spaces, so it looks just like the way we name variables. We name functions just like we name variables. Can't have spaces, so we have underscores instead. And this particular function converts Celsius to Fahrenheit. But we're going to worry about, the things we're going to worry about later are parameters and return. We'll think about that later. For now, it's def and the name. And what does functions do? Functions are a way we can save code inside a name to reuse it. It's a way we can save code, give it a name, label this bit of code. It's another way to think of it. Functions let us label our blocks of code so we can reuse them as many times as we want. Saves the function to be used later. It allows us to dry out our code, because if we have repetitive code, we can save it as a function and then reuse that function as many times as we want instead of having to repeat that block of code that's repetitive. So a function is a portion of code that can be reused. Def is the Python keyword to define a function. The code inside that function is thus saved for later use. And then here's an important word, invoke. Invoke. So invoking a function means making it happen, making it go, activating the function. That's called invoking the function. So if functions are, we get a bunch of code, bundle it up for reuse. Invoking it is that reuse, is reusing that function, using it to do the thing. Colloquially, people will call this calling the function. And so people typically don't use the word invoke very often. They usually use the word call. I'm not going to be using call in this lecture or in the slides because it's very confusing when talking about functions, because we're going to say, like, this is a function called Celsius to Fahrenheit, call that. And that gets, just verbally, that gets really confusing. So I'm going to say invoke, which is a slightly more proper term for what happens when we activate a function. We're invoking the function. As an example, here's a hello world function. When I run this, it says hello world, and let's take a close look at this. So the top hello world, this is the name of the function. So we can call this anything we want. In this case, it's called hello world. We could also make it be something like, say, greet the world. I'm just going to give it a different name, so it doesn't matter what we call it. We can call it anything we want as long as it doesn't have spaces. And then inside of the function, everything that's indented is inside of the function. Just like if statements or while loops, everything that's indented is inside of the function. When we're defining a function, we always start with the word def. We have a space, we have the name of the function, we then have two parentheses like this, and a colon. Later we'll learn that we can put stuff inside these parentheses, but we're not going to right now. When we're invoking the function, we have the name of the function followed by two parentheses. Always those two parentheses at the end. Whenever you see two parentheses at the end of something like that, that means you're invoking a function. You can think of it as like, the please hand emoji, right? Or thank you. Like, please happen. If that helps you remember it, go with that. It's like invoking. It's like, thank you for running, thank you for running the function. So it's the two parentheses at the end of the function name is what causes the function to happen. When we define a function with the word def, the code inside the function does not run. Uh-oh. This does not look good. There we go. So when we define a function with the word def, the code inside the function does not run. Notice when I do Python functions, it says nothing. That's because my print hello world is inside of the function, so we're just defining the function but not actually executing it, not actually activating it. We're getting it ready, but not actually activating it. To actually activate it, we have to invoke the function. We invoke functions by having the function name followed by parentheses after. And notice that we can write the function once and invoke it as many times as we want. This will say hello world for every single invocation because we defined the function once and invoked it many times. Inside the function, we can do more than one line too. Like here I added some lines there, just a print statement with some lines. And now all of the hello worlds will get those lines at the end. So we define the function, which just prints out two lines of text. Then we can invoke the function as many times as we want after that. Questions about this? So invoking, let's work through this like a computer. When the computer gets to this line, it'll say, oh, I see the word def. Time to get ready to make a new function. All the code that follows this, that's indented, is going to go inside my function box. So like, the word def gets the box ready, labels it, greet the world, time to start scooping some code into this box. So it puts in the 2 print statements inside of that box, that function box, and then we're done with the indentation here. Now it closes that box and won't be putting stuff in it anymore. Now once it gets to line 7, it says, oh wait, I know this is the function I made. And see there's parentheses after it. That means I want to run the code inside of it. So when it gets to there, it'll actually jump back up to line 3, and then it'll go to line 4, and then once it'll exit the function, as in it'll see that there's no more indented code, and then it'll jump back down to line 8, down here. So the order of execution is basically line 1, skip over down to line 5, because we're just saving this function, we're not actually running it yet. Go to line 7, this means we're invoking a function, which means we jump into the first line of that function. So after line 7 comes line 3, then line 4, then since we're exiting the function, we jump back down to line 8. So the order of execution thus is line 7 is the first bit of code that's actually executed, then we go to line 3, 4, then 8. Then we go to line 9, then 3, 4, then 10. Then we go to line 11, then 3, then 4, then line 12. Then we go to line 13, then 3, then 4, then line 14. Questions about this? So functions save code, makes the thing jump around when it's being invoked. No questions? What happens if we put the invocation in the function? Anyone want to take a guess what this will do? It'll keep calling the function. Yeah, it'll be an infinite loop. This is an infinite loop here. So don't do this. Don't put your invocation in your function, at least for now, because that'll be an infinite loop. So go ahead and do start activity 2, and we can see, it broke actually, but you can see that it was an infinite loop before that. So that's because it's calling the function inside of it. Don't do that. Activity 2, functions, and remember to start with a print statement. That'll get you. So to invoke the function, we need to write the name of the function, followed by those please invoke parentheses. I mean, you can keep it very simple. You don't have to do much stuff, unless you want to. Those are thumbs up, of course. This one is not usable, but find it. Yeah. I mean, you can do it using a little table, that'll do the trick, but the idea was functions.
So is the order of the function matter? Like, do we need to define it first and then call it, or?
Yes, you have to define the function before you call it. You can't call functions that have not been defined yet.
Appreciate the syntax practice.
Yeah, cool. I don't know if that was sarcastic or not.
No, I actually do.
Actually do. Nice.
Because there were a number of times when I was writing my Python, I'm like literally combing through to figure out where I screwed up.
I can tell
And
you.
I feel like I'm still messing up there.
No
somewhere.
equals. So
No
to
equals?
invoke, you just, the function name with the please invoke parentheses.
That's why it did not work.
Just think of those please hands. Good.
There it is.
Is there a hack to comment out?
Yeah, I was.
So in VS Code, it's command slash. Gedit, it's something you have to, it's an add-on you have to install, and then it's control M. So if you do an apt-get install, I think it's gedit plugins, I want to say this. So if you bring up terminal and you see apt-get install gedit plugins, then I think it's control M. So sorry, delete that. Type in sudo, sudo with an O again, apt space install space gedit dash plugins. I hope that's it. There we go. Password. If it says like package.com,
I have no idea what this is.
Password.com.
yeah, different error. Cross fingers, control, what? So you haven't checked this. Yeah, so it's a couple seconds, and then you have to enable these settings, but it's control.
Okay, cool.
And there's a bunch more plugins now installed if you want to really like deck out your editor with all the settings. So,
Thank you.
yeah, I mean those are. I mean you pretty much already fixed it by yourself, but those are like mess ups, right? More mess ups, but you already did it, so you're good. So since we have a few more things to cover today, I'm going to be going over this one kind of quickly here. So I'm going to be going over the solutions now for the first few challenges. The second challenge is just fixing a myriad of typos. The first one. What was the first one?
First one, I don't think had any problem.
What was it?
I don't think it had a problem.
Yeah, you're right. Huh. Second one needs a colon. Third one needs to indent. Fourth one, look at that sneaky guy right there. There's no underscore. So got to add an underscore there. And then these invocations all have issues. So this, I guess the first one is fine there. This one needs parentheses. What's that capital F doing there? Case sensitive. That's snuck in there. And then you never put parentheses between the name of the function and the equals. This does nothing. Man, there's a lot of fire trucks and stuff going around. What's up, Roman?
Sorry, how do you uncomment everything again?
So on VS Code and Sublime, it's Control/. It will toggle commenting. On gedit, you have to install another. Okay. Oh, that looks good. Cool. So everyone's alive, including the projector. On gedit, you have to install a separate plugin, so if you're using gedit, I can point you to what to install, and then you can use Control-M once you've installed that to toggle comments. Actually, I can show you right now. So if you're using gedit on Linux, you can type in sudo apt install gedit-plugins. This is only for Linux users who like using gedit. You can do sudo apt install gedit plugins. And okay, to be clear, gedit is the default text editor under Linux. So if you're using the default text editor under Linux, this is something you can do. Sudo apt install gedit plugins. Once you have them installed, you then can go to, you'll hit enter and it'll install them. Once you have them installed, you can go to preferences, plugins, and I don't have it installed, it looks like, so let me do that. And then there'll be one that's like comment and uncomment. And once you have that, it's Control-M, but there's a zillion other things, including Python console, quickly open. Look at all these. So that was under preferences, and then plugins here.
Doesn't get rid of the space though.
Doesn't get rid of the space. So I guess you can use tab and untab to maybe fix that, hopefully. Otherwise, if you get, cool, that worked, nice. So then that's that. We're gonna do challenge 3. Let's refactor this. So I think an important concept, why are we learning functions? Well, it lets us dry out our code. It lets us create reusable parts of our code. It lets us make code and reuse it whenever we want to. If we got it working once, we can use it every time we need it. That's the purpose of functions. Furthermore, maybe someone else can write a function that you use. So there's more than one use, especially when you start thinking about team dynamics when it comes to functions. So we're going to make a function that'll be, we need to ask your name 3 times. So it'll be def. What's the repetitive part of this? The input and this print. These two are the same and repeated 3 times. So that's the part we want to put inside of our function when we're refactoring it. Remember, refactoring is when we take something that works and then replace it with something that also works but is better. So like neater, drier, less code, more clear code. That's the process of refactoring. So we're going to refactor this to do that. You can think of refactoring as just a fancy programmer word for revising, like revising a draft, same idea. So def ask name, and then we just do ask name. When we can replace both of these with ask name, ask name, and now this code is much more readable and less repetitive because we put the code that repeated into a function and just called that function when we needed it. I'm not going to go into challenge 4, but it's a fun one if you have time. Questions? Cool. So yeah, here are the challenges, the solutions, and challenge 4 is in a separate file for the solutions. Let's go on to the if there's any other questions? No questions, people. Surely there's some questions about functions. Let's actually have a quick discussion now. So with people near you, see if you can express in your own words, 1, what a function is, and 2, why they're useful and how you could see them becoming useful as you write more and more complicated programs. So we're going to just spend 1 minute for this quick discussion with people near you. What is a function in your own words? How are they useful, and how could you see them becoming more and more useful? And let's spend, again, 1 minute doing this. Discuss. All right, so we're going to close off discussions. Hopefully that's, and go on to some new topics with functions. So, what were some things that you discussed in your group, real quick? Anything you want to share about why functions are cool, why we want to use them? How did you each individually put the fun in functions today in your life? Reusable code. Yeah, I mean that's great. That's the idea of functions. We get to write it once, use it over and over. Also, I think it's good for labeling code, so it keeps your code neater. If things are in functions, it's easier to read because we know that those functions all contain one bit of code. As an example, we're going to do, to look at the solution to challenge 4. See how this is actually more readable when there's functions, because you see that all the code in that function has to do with one particular thing. So it actually, breaking your code into functions improves readability, improves code understanding, and then also allows you to reuse the code. Let's go on to another thing now, parameters. Parameters are the things that are in the parentheses. You can put stuff inside those parentheses when you're defining a function. When you're defining a function and you put something in those parentheses, that something is called a parameter. A parameter is a type of variable. A parameter is a type of variable that's associated with a function. A parameter is a type of variable associated with a function. When we invoke a function, we can actually reassign those variables. So as an example, let's create a parameter for greet the world. So let's maybe make it a general purpose greeter. It can greet many different things. So greeting machine, we'll call it that. But right now it's only going to greet the world. We want it to greet different any name, anything we give it. So we can do greeting machine, we can do name equals world, or whatever, and then here we do hello name, and then down here we can actually redefine name to be something else. We can do name equals Jane. So let's pick this apart. Notice that I just put a variable assignment inside my parentheses. This might seem a little bit weird, but this is what you can do in Python. You put a variable, you define a variable in your parentheses. You define a variable in your parentheses, and then you can redefine it when you're invoking it. So Jane, but we can maybe do, down here we can do something else, like Johan. And then we can do another one, J. Lots of J names. So, so notice that we wrote this greeting machine, and inside of the greeting machine, this is how the code operates. It's a little bit counterintuitive, but this is what happens. The code's, if I'm the computer, if I'm Python, I start at line 1, and then I jump immediately down to line 5. Why do I jump to line 5, skipping these two? It's just defining a function. It's not actually running it yet. So it just remembers that this code exists, but it skips down to line 5. Then it goes to line 7, and it's, oh, greeting machine. That's this function up here. Then it runs name equals Jane and jumps to line 3. So then it's essentially as though we had written name equals Jane here. Or we had written it up here. Name equals Jane, like this. And I guess we should also, just to show you what happens if we don't specify anything here, it'll then be world. That'll be this is the default if you don't specify any variables in your invocation. So again, line 7, it jumps over to line 3 after executing name equals Jane. Then it's print hello Jane, how are you? Then once it's done with the function, it jumps down to line 8. Then it gets to line 9, runs name equals Johan, jumps back up to line 3, then it says hello Johan, how are you? Jumps down to line 10, then goes to 11, then runs name equals J, jumps up to line 3, says hello J, then goes to line 4, how are you? Jumps down to line 12, so it's every time it gets to one of these invocations, it jumps up here. If there's a variable defined in that invocation, this is called an argument. If there's an argument defined in the invocation, arguments are the variables that are defined in invocations, or the values that go into invocations. So here we have a value that went into this invocation, and those will then go inside of that function. So you can think of these things as kind of little doorways that you can put data into a function. Like functions have these variables these variables are called parameters. So functions have parameters that allow us to add data inside of the function every time it gets invoked. Now line 13, this one we're invoking the way we did before, just with the parentheses with nothing in it. What it do then is it'll actually use the default parameters. When you have nothing in it, it'll actually use the default. The default is name equals world. So then it'll just do hello world, how are you? Questions about this? Okay, I don't know who's went up first, but Matten? A lot of M's. Yeah.
If you were to delete the name from greeting machine on top and just leave world in it.
Like this?
Yeah, and then run.
This will not work at all.
Line 13, it wouldn't run.
This is not going to run at all, no. Invalid syntax.
Has to have variable.
Yeah, has to have a variable name. Yeah. Joe.
Since it just has one parameter in the call, do you need the name equals?
So that is actually, we'll get to that in a moment, but you can actually skip the name equals and it'll go by position then. So that is something you can skip actually, and so you can skip the name equals there, not in the other location. But for now, we're just going to spell it out all the way. Yeah, Roman.
What's considered the argument? Everything in the parentheses or just world?
Great question. So there's parameter and argument are the two terms here. parameter is the name of the variable. Argument is the value you pass it during the invocation. And pass, that's a word I'm using right now. Passing is when you invoke a function. If you have an argument with so this is passing nothing. I think that's a good way to understand it. This is invoking greeting machine, passing nothing, not doing any passing whatsoever, not passing any arguments. These three are passing one argument. The name of that argument is the name of the parameter. So the parameter is the name. This is the parameter. The parameter is name. The argument is Jane, Johan, J. So these are terminology. Parameter is a type of variable. Parameter is a type of variable. Name is the parameter. And then the default value of the parameter name is world. These are all correct ways to put all this, yes.
Can you use as the argument pass?
Pass, no. So when I say we're passing an argument, that has nothing to do with the Python word pass.
So you cannot use it, for example, just to leave a blank and leave it open for next time if you want to use a different.
Like this?
variable?
No, pass only works by itself on a line. It'll never work in any other situation.
No, when you define.
Up here?
Yeah.
There's actually the way you do that is this, but we'll practice that next. So you can actually, if you don't want to specify any default, you do it like this. But we'll get to that next. Yeah,
That
Alex.
was my exact question.
Cool. Yep. So we can get rid of the equals and that altogether, and then that then is a parameter that has no default, and you must specify it every time. But this is a parameter with a default, and we can call it like this. These are also known as keyword parameters. We're going to get to the other type after. Let's get to activity 3. Actually, let's have a break, and then we'll get to activity 3. So we're going to have break until 8:05. Break until 8:05, and the next thing though is just going to be activity 3. And yes. Here's let's see, which quizzes have you not done?
Just Mondays.
Just Mondays? Same with you, Michael? Cool.
Was there any handouts on Monday too?
There was. So let's see. So Mondays. So here's one of Monday's quizzes, and then let me see if I think I have another one in the stack here. There we go. Let me get the handouts too for you guys. You can just go back there and I'll bring you the handouts. No problem. Real quick. So make sure you're in the right directory. You're not in the right directory yet. Are you in the right directory? No, the right directory is whatever you cloned it. Where did you clone it? My page. So now you want to do cd my page. My computer will show you. There you go. Now do ls. Starting ls space dash a. Dash a, that'll show everything. Lowercase a, that'll uppercase A space. Well, I see dot get. That's good. I'm just making sure you're in the right location. See if there's a dot get there? Dash a will show hidden files. Because there's a dot get there, that means you're in the right location.
What if there's no docket?
That means there is no Git repo there. about adding your own domain name.
Yeah, does it have to do with this?
Yes. So you basically have to go to the domain name, and then you can also look up. You should look up for how to add your own domain name. So you add the domain name, and the domain name you have to configure the domain name to point to GitHub instead of whatever it starts off as, and then you go and configure it there to say to tell GitHub that I select the domain name, and if requests are coming, when the requests are, if people are requesting my stuff with that domain name, send it back. And then so you type in GitHub and you go.
So wherever you got the site from, you gotta configure it there to look at GitHub.
I mean, as an example, yeah, so like if it's, hover or just, my general advice is just, thank you, use anything but GoDaddy is my general advice about where to buy domains. So Hover or Namecheap or Google domains are all popular. And then, and the reason I say, there's many reasons not to use GoDaddy. So as an example, like the whiteboard website, whiteboard.michaelb.org, this is actually a GitHub Pages repo. It's actually PB. Yeah, well, redirected to it, but it's actually my whiteboard repo, and then in the docs directory is where I have all of this HTML, and this is actually a little static site generator that I wrote just for this page. So there's just 3 pages here. So,
Cool.
yep.
But we still have to buy a domain.
Yep, you still have to buy a domain, and it costs like
So in the custom domain,
$10.
do you actually put like something more than just,
No, just the domain, whatever.com,
oh, okay.
or org, or me, or whatever. And like,
What if the domain is not yours?
if the domain's not yours,
I mean,
like how do you get google.com to point to your stuff? Or
I don't know, like,
Because the traffic will go there first,
Yeah.
and they'll be directed to here.
Yeah.
But if you don't have that one, they're not gonna be directed.
So yeah, right. It won't. It'll actually. You have to first buy it and then configure here to point to GitHub. Otherwise, yeah, you can't just put in google.com and steal all of Google's traffic. That would be too powerful.
my brother said that I use this, but they asked me if I know how to use whatever program they say. I'm like, I don't know what you're talking about.
Maybe just get your own.
So
It's $10.
It's actually advertised.
Well, really?
Like somebody bought it.
Oh, right.
It was accidentally released for a little bit.
Oh, wow.
There was some kid who like ended up buying Google.
Wow, that's hilarious.
It was like
They
a bug.
they let it expire?
No, they literally
Like-
them like we need this back.
Yeah. Just give it back, kid. Otherwise, they're bringing in. We're bringing in the goons. Like, hey, kid, this can go one of 2 ways.
That's exactly probably what happened.
Either it's either going to be your brains or the DNS on this piece of paper. Yeah, it looks close. But make sure you chop and copy. I still see there's missing stuff there, so you have to copy those now. Does that make sense?
Yeah, so, I remember about that last time, we do this. Ampersand.
Oh,
And then, it opens it still. You go back, then it's back on the phone.
because I didn't have this problem before.
application, if I got Chromium or something, it doesn't, for some reason, it don't. I think what that tells us to do is like, open a new process, like use this process. Otherwise, it thinks it's still open. But if you close that file, then you got the ampersand, if you close the file, and it'll go back to the.
Yeah, yeah.
So, does that make sense? If I do that, open the file,
And you close the
it's
file,
hung up.
it's okay, I need to use it.
Yeah, okay.
That's about it.
But I find the window here, like windows that we're using now, like. We should start working on the next activity.
Yeah, if you want to. That's the next thing we're gonna do. Just looking you didn't try. I'll test to do that. So next thing we're just going to be doing is activity 3. So if you're back and ready to go, just go ahead and get started on activity 3, and I'll be here. seeing you going down this other route, like that, no. This is the almost the entire solution to the dash button. So see if you understand it and then apply it for it.
Thank you.
Yep. What's up?
Oh, yeah, yes, finally send this to us, even though that's happening, let's talk about what that is. This is saying that it user command language level, which means that it actually gives you some tips.
Well, I wasn't gonna try this before trying it.
I will tell you what it is. It's saying that this file, here's of HTML, is changed in both bash and master in different ways. That's what it's telling you. Does that make sense?
So if I, at any point in the branch, that changes or thanks.
So we're doing activity 3. I'm going to be going over the first couple challenges in a moment, so get started with that if you haven't already. This is going to be more practice with functions and Right, JavaScript. No, Python will vary more or less than those steps. Exactly right. With positional, you can throw it in any order. So that's a feature that JavaScript doesn't have. You can do it in any order, however, the wrong consequences for it. Thanks. Any questions? Yes. I'm going to be going over the first couple activity challenges. First challenge is always do the first thing, which is add a print statement. Print I am in parameters. Whatever you want to put there. This might be misspelled. Just so that you know that you're editing the right thing. So I'm in parameters. So that we know we're editing the right thing by running Python 3 parameters in the right file. Next thing we need to do is invoke the challenge. So we're going to do challenge 1, which is invoking this. So challenge 1, and then to invoke it, we can do name equals something else, like name equals Michael. And then we run it. And remember, when we're invoking using a parameter or an argument, remember this is the argument, the parameter is name, Michael's the argument, name is the parameter, Michael's the argument, name is the parameter. It's going to say, we're going to put it inside the parentheses like this. So it's the previous invocation would be like this, and then it'll say hello none. But then if we add in the invocation, it'll say hello Michael. That's how we invoke a function with parameters. Parameters, I guess, big picture, parameters let us write a function that'll mostly do that can do something slightly different every time we invoke it. That's the big picture. So we can actually make more reusable functions, more versatile functions. would say do more functions, get more practice with all the different functions. I'm going to go ahead and do challenge 2, which is one of those fun typo challenges. Let's start with this one. It's not supposed to be name ... none. It's supposed to be equals none. Over here, pesky space. It should be an underscore, not a space. There can't be, because parameters are another type of variables, the same rules about variables apply to parameters. Because parameters are a type of variable, which means they cannot have spaces in their name. Over here, we're missing a comma. Might be a little bit strange to see a comma there, but we were supposed to put a comma separating our different parameters. Here, this parameter is missing its something like equals none, its default value. This parameter is missing its default value, which means we have to have an equals something. To change the invocations, top invocation looks okay. This invocation is missing parentheses around it. Invocations must always have parentheses. We can't use the word is here, it has to be an equals. Over here we need to use equals, single equals, and this is a kind of a mean gotcha I have here. That apostrophe there is actually an error too. So you have to either get rid of the apostrophe or change these to double quotes. Those would all be solutions. Another solution is you can actually do backslash apostrophe. That's called escaping the apostrophe and allow you to have an apostrophe in your string. I'd recommend just using double quotes though. That's the easiest way to solve this. So these were all just syntax error practice. This is challenge 2. Keep on working on this, and I'll go over challenge 3 in a moment. Oh, what? I'm noticing I'm missing underscore there. That's another mistake.
Question.
Yeah.
Which one is it that didn't have a second default? If you have one default for one variable,
Yeah.
you have to have it for all of them?
It's actually, so that's a great question. We'll learn about having variables without defaults, or parameters without defaults in the next activity, because that's also an option. However, what parameters, it has to start, the ones without parameters have to start on the left.
And once you have one with the parameter, all the subsequent ones have to
Right,
have it.
yeah, I'm sorry, with the default. Yeah, once you have one with the default, then all the subsequent ones have to have one. The technical term is these are called keyword parameters. These are keyword parameters, or keyword arguments, keyword parameters, because there's an equals in them. Ones with defaults called keyword parameters. Parameter called acceptable options. So acceptable options is the parameter. So just print it out. Just print out acceptable options.
So, you mean like
Yep.
print basically here?
And then you want to, so basically the challenge 4 has several steps to help you start. You could have just done, challenge 4 could have just been step 4. Does that make sense? But it's a progressive.
Zero powers and one.
Yeah, exactly. Sorry. I think point 9.
Yes.
Yeah, helps out this little stuff.
Yes.
Math.
Here for you.
Okay. So, invoke the, or define it, invoke it, assign it to a list.
Zero powers one.
And then I define input equals answer, and all that answer is not in this list.
I think some of this should be in that function.
Oh.
Does that make sense? Some of that should be in that function. going to be going over challenge 3 now. Examine the function that performs addition, uncomment the code. I'm actually going to go over both 3 and 4 now, so that's it actually. So I'm going to go over the rest of the challenges because we have some more stuff to go through. So this is a function that performs addition, and then prints out the result. We're going to now write functions for some more operations. So subtraction, and we just change that to minus. And so on. I mean, they're all kind of similar. If you weren't sure how to do these two are a little bit weirder. Exponentiation is a operator that has two asterisks like this. That means raising something to an exponent. So 5 squared is 5 to the second, 5 to 2, and use two asterisks there, and that's exponentiation. If I might be misspelling it. And then modulus is a operator that you mostly just see in computer-related things. So you don't see this in math very often, and maybe math, you see plus and minus all the time in math. You don't see modulus very often in math. Modulus is a percent sign. That's how it's spelled. Modulus is a percent sign. And what it does is it takes the remainder. So it's an important one to know because sometimes you're quizzed about it in interviews and stuff, which is why I'm bringing it up here. It takes the remainder if one was divided by the other. So as an example, here we go. It's a little bit frightening. As an example, if we have 15, let's do 5. Or, gotta pick the right one. 7, 3. What's 7 divided by 3? 2 point something, right? So now, remember when you first learned arithmetic, when you do divisions, you sometimes came up with a remainder? So, right, so 7 divided by 3 is 2 remainder 1. Because 6 divided by 3 is exactly 2. And then there's 1 left over when you do that division. So modulus takes the remainder if you were to do that division. That's basically what the modulus operator does. So set A modulus B is 7 modulus 3 is 1. 7 modulus 3 is 1. So this is an interesting bit of trivia that is used. It does actually come in handy in coding occasionally, and often pops up in kind of coding challenge type stuff, kind of little coding challenges you see in interviews or just to improve your abilities. But yeah, that's modulus. Finally, we're supposed to write a function called asker that takes a parameter called acceptable options. So, and we can let's just do none for now, I guess. We don't know what that'll be. At first, I should just print the parameter. Okay. Then write an invocation of that function. To invoke a function, we write the name of the function followed by an open parenthesis, such that the parameter is assigned to a list. So we could do, for example, let's start by making a list, actually. Let's start by making a list. So we could use, as an example, like the author's name list, or we could do, Pokemon. I'll do Pokemon names. So we have Pikachu, Jigglypuff, Squirtle. So there's 3 Pokemon there. So then acceptable options equals Pokemon. So see how I'm assigning it to a list? This is a variable that contains a list, and then I'm invoking it. Let's actually run this first to see what happens. Make sure we're not going too far off. No, I have another syntax error. No.
It says line
39.
Is it rows you're missing the quotation?
Sure is. Thank you. You've gotten good at this,
I told
spotting
you, I
those.
said I
Yeah.
couldn't get it right. I wasn't
Thank
being
you.
sarcastic.
Yeah. So Python 3 3 parameters. We see Pikachu, Jigglypuff, and Squirtle, so that seems to be working. It's printing out acceptable options. Now we want to make a while loop that keeps on asking the person for input until it is in that acceptable option. So user input equals input, like, I'll just do a parenthesis there. It's like, you know, ask, like that. And then we do while user input. So this is something that it mentions use while and the in or not in operators. We can use that to check inclusion. So while user input not in acceptable options, we can make it repeat. So we can do user input equal, like, we can do something like print invalid, and then ask again. So let's try doing this. So an ask, hi, invalid, hey, what, Pikachu. So when I typed in Pikachu, because Pikachu is in one of the acceptable options, it actually ended the function. It got out of the while loop. So what this function does is, given any list of strings, it will keep on asking until somebody enters a string that was in that list. Yeah.
How would you do like a subscript underneath and say like hint?
Like to give them a hint of what you should do. Mm-hmm. Maybe you could just print out like acceptable options in here, like invalid must be one of these. So then we'll print out acceptable options, so you'll know what it must be one of. So like, we'll try this again. So ask, hey, invalid must be one of Pikachu, Jigglypuff, Squirtle, Jigglypuff, and then it ends then.
So I'm guessing if we were to do something like this on a web application, we could adjust the font.
Yeah, so all the activities we're doing right now will not be directly applied to the web. This is all just broader practice with Python. Okay. When we're using Python to build a web application, the Python code will be outputting HTML and CSS.
Gotcha.
So the same stuff we've been doing all this time, if that makes sense. So great question though. So this is only for making terminal applications. Like maybe you want to make a little terminal application that does one task that only more advanced users will use, because you wouldn't necessarily ask an average user to have to deal with a CLI, if that makes sense. Mm-hmm. So there's more, maybe targeting more advanced computer users. I'm going to work through what this is doing. This is a list. The list goes inside the variable Pokemon. The equal sign means the thing on the right goes in the thing on the left. Then we do asker. Oh, look at this, another equal sign. So the thing on the right goes in the thing on the left. In this case, acceptable options is a special type of variable. I've said this word a bunch of times. What do we call this type of variable again? Parameter. Yeah, it's a parameter because the name of the variable is a parameter. But it is true that I guess down here you could also, when it's being called, it's called an argument. But inside of the function, it's called a parameter. So inside of here, acceptable options is called a parameter. By the way, I'm using the words argument and parameter I'm distinguishing the two. Colloquially, people misuse those two words all the time and just confuse the two. So if you're looking up documentation, people might just use argument and parameter completely interchangeably without any effort to distinguish the two. They might think that they're the same, might just refer to them as the same thing. I'll try to be careful to actually clarify them as they're supposed to be done, but out in the real world, out in documentation, nobody cares. Nobody gives a crap. They just use argument, parameter completely interchangeably. It's just the same thing, and just refers to these sorts of variables. The technical definition is the argument is when you call it. The parameter is the name of the variable inside of the function. Is the type of variable. Parameter is the type of variable. Argument is the value that you call it with. Invoke it with, the value that you invoke it with. That's the technical definition. So here we invoke it with acceptable options being equal to this list. Then we ask for the user input. While the user input is not inside the list of acceptable options, so this while loop will keep on repeating until they enter something that is inside of the acceptable options. Because remember, while will keep on repeating when this is true, and for this to be true, it has to be not in the list of acceptable options. So as long as they have not given you a valid answer, it's going to keep on asking ask and getting a new input, then checking to see if that new input is in the list of acceptable options. If it is not, it'll again say invalid and then ask again. So this is a way that you can make a program that prompts for prompts a question and keeps on asking until they type in a valid option from like a menu, as an example.
And so they have the same logic before the code.
Yeah. Absolutely. Questions. So this is a tricky one. Definitely on your own time, go through it more to understand it better. This is a harder challenge for sure. And the bonus challenge is actually very similar to this top one. It's just expanding on it, this challenge 4. Any other questions about challenge 4? We are running a little bit out of time, so I want to go into the next set of challenges, but that's, yeah.
Yeah, not in. In you.
Not in. So
what I got did not there.
So we could also do in instead if we want. So in is while the user input is an acceptable option, repeat this code. Not in means while the user input does not exist in the list of acceptable options, repeat the code. So not in checks to see if this variable is inside of that variable. And not in will check to see if it is in that variable. Not in will check to see if it's not in that variable. So is Pikachu in Pokemon? Yes, Pikachu is in this list. And because Pokemon is the same thing as acceptable options, Pikachu will be in acceptable options. So Pikachu will not be in acceptable options.
So if you got rid of the not,
Yeah.
it would just be continuing with a while loop unless you.
So if we got rid of the not, then I'll have to type in Pikachu to make it keep on repeating, or Jigglypuff to make it keep on repeating. But if I type in anything else, it'll stop. So, which is the opposite behavior we want. We want it to keep on asking if they have not entered a correct thing. So while invalid, keep on asking. While the user input is not acceptable, you can even read that as while user input not an acceptable option. So it reads kind of like English, right? If someone asks, like you're at the grocery checkout line and you're like paper or plastic, and they're like, can I have a cloth, please? And then they're like, nope, not an option. We don't have cloth, not acceptable. Ask again, paper or plastic, And then once they give a correct answer, then you can continue on bagging their groceries. In that case, yes.
Things like not in and in work both on lists and
Dictionaries. Yep, both lists and dictionaries and strings too. You can actually check to see if one string is in another string. So like, if is jig in Jigglypuff? It is. So you can do in, not in, works on strings, lists, dictionaries, etc. Great question. Yeah.
So my first try was putting Pokemon totally into our the very top,
Like here?
right in front of.
This is correct.
options.
Okay, just as an FYI though, this is also correct. If you did something like this is also completely fine. You can put it right inside there, like that. But yeah, you're inside of, like up here,
Yeah.
like that. Like this?
Yeah.
This should work.
It did work.
Okay, cool. Yeah, this will work too. So this is just basically giving a default that's many. I'm giving a default of none, but you could also give it a default of many different things. Great question. I'm going to be just going on to the next thing because we have more stuff to cover. But definitely play around with the solution on your own time and see if you understand it better. And you can take a look at the bonus activity too, which is an expansion of that. We're now going to get to two more things. So the two more things about functions that we have to talk about today is another type of parameter called a positional parameter and this return statement here. So I already mentioned that there's such a thing as positional arguments. Positional arguments are ones that do not have the equal sign. So notice how here, so these are both equivalent. Greet person, name equals Joanne, then we use Jane. This is okay, we're having equal sign. So this equal sign says that this is a keyword argument, and when there's an equal sign, that's referred to as a keyword argument, and to use a keyword argument, we do it like this. We do name equals Jane. Now, Python also supports something called a positional argument, like down here. That's when you don't include an equal sign up here. Notice how there's no equals. It's just name by itself. So you only give the name a variable. You only give a variable name there. It could be anything you want. It could be ASDF, could be person, could be thing. Anything you want can go in there. Then outside of it, you don't actually do thing equals Jane. That actually won't even work. You do just Jane by itself. And it's a positional argument because it goes by the fact that that's just the first thing there. So Jane corresponds to thing. If we had more than one, so thing 1, thing 2, we can again call this anything we want. Print hi thing 1, print goodbye thing 2. We can then do, Jane and J. We're into J names here. So here we have Greek person Jane, Greek person J. There's no equal signs there. Those are basically implied. The equals are basically implied. Thing 1 gets assigned to Jane. Thing 2 gets assigned to J. Maybe I should name this something else because it's getting confusing. Goodbye, I don't know, nighttime. So this could be anything we want. Hello, hi, morning. So morning gets assigned to thing 1. Thing 1 is a positional parameter. It's a variable. Morning is a positional argument. Arguments are the values that go inside the parenthesis when you're invoking the thing, when you're invoking the function. So thing 1 becomes morning, thing 2 becomes nighttime, and then we use them inside of the function here. Questions about this? So these are actually more common. These positional arguments and positional parameters are more common than the keyword ones. We started with the keyword ones because I think they're a little bit more easier to understand because they have that equals, which is just like the thing we saw before. But it's more often written like this, but they're almost equivalent. Yeah.
Okay, so when do we use the keyword and when do we use it?
Go with whatever works is my first advice. So like if you're writing your own functions and using your own functions, go with whatever works. The use of keyword arguments is you can provide defaults. Like in this case, if we call greet person without a default, it'll default to Joanne. So that's a feature of keyword arguments that positional arguments do not have. Positional arguments cannot have defaults. They're all mandatory. Positional equals required. That should be in your head. Positional arguments are all required. They're required arguments. They're mandatory. The program will fail if we try to run it without them. With keyword arguments, it'll actually go along happily using the default instead of whatever we specified. So I guess that's one thing. If you want an argument to be optional, if you want it to have a default, you will have to use keyword ones for sure. The other thing is, maybe you have a ton of argument, like tons and tons of arguments and parameters, and it becomes really hard to read. Like you realize you have 10 different things here. Nighttime, midday, afternoon, and it just is getting really, really long, and you're don't remember which order they're coming in. Well, then that's when another use of keyword arguments is it might be easier to read if you use them if you're getting too many arguments and it's hard to remember which order they're coming in. Do you have a question?
It's only positional, whatever comes first.
Oh, yep, that's why it's positional. Yeah, so this could be a as long as, and this only has to correspond to that. The positional keywords only exist within that function. Outside of the function, a does not exist. It's only inside of that function. And thing 2 only exists inside of that function. It does not exist outside. So only inside of here. We can't do thing 2. We can't do print thing 2 down here because thing 2 only exists inside of that function. It's another term you can say is private to that function. It's private to this function. So inside of greet person, thing 2 exists. Nowhere else does it exist. Yeah.
What if you define thing 2 prior to defining the function?
So this will get really confusing if we have thing 2 equals, these are actually two thing 2s. These two, the two thing twos are two things. We should use different names than thing two, shouldn't we? So if we had, I'm going to rename this just to B. So if we do B equals hey up here and print B, this B is actually, don't do this, by the way. Just don't do this is my first advice. Don't reuse the same variable name like inside and outside because that's going to get really confusing. But the actual thing will happen is this B, according to Python, is a different B than that B, which is really confusing. This is a private B to greet person. This is a global B that's global to everything. That's the term. It's global. It's available everywhere. This one's only available in greet person. Was there a question? Yeah.
So if you print B, so in this case, so which one gets executed?
Print B will be hey, because this is the global B that's only available globally. This is the B that only exists in greet person. Exactly. It's that. It's pretty difficult to handle this.
So in this case, both A and B are optional.
Sorry?
So both A and B are optional.
Both A and B are,
Optional parameters.
they're not optional, they're required. Both A and B are required. Optional is if you have the equal sign. So required is if you don't have the equal sign. These are required. If we try to not specify one, this will fail. It'll say invalid number of positional parameters or something like that. Like greet person expected 2 positional parameters, but got 1 instead. I think that'll be the error. Yeah.
And in the argument, can you pass, like, for example, it's expecting 2 or 3 arguments, but can you pass one of them blank with just like empty quote strings?
Yeah, we could do this. That'll still work. You could do empty quote string, you could do none, you could do 0. These will all still work. Whether or not that your program will work after that is another question, but hold on, my program is not working. Whoops. Yeah, question.
It appears that you can do it a whole bunch of different ways. Like in the function, you can define the keyword, but then not set it in when you call it. Just supply like a parameter,
Yeah.
and vice versa.
Yeah, there are definitely a few combos you can do. Yep.
The only thing it seems like you can't do is not provide one that's required.
Yep, that's one thing. Yeah, so you can't skip required arguments. Required arguments being positional. You also can't do this. You can't use a positional argument as though it were a keyword. You can only do this. So only can you do this syntax if it was defined like that in the thing.
Try that.
Oh, this will for sure fail. Other questions? And those are just kind of the rules of Python. So next thing we're going to talk about, so that was another way to do arguments and parameters. Let's do a big picture. Why do we have arguments and parameters? Does anyone want to like, offer a reason for this? Why do we have these things? They're very useful. They're essential for functions. They're great. We love them. Why?
So we write it once and then we use it. We can call it from memory.
Yeah, so definitely the purpose of functions, we can write them once and then reuse them as many times as we want, but then what do parameters or arguments add to the mix? Yeah, Roman.
Create a variable in a function.
Create a variable in a function, yeah. We can also, though, create variables in functions like this, like thing equals 10. So we can create variables like that, too. We don't have to use parameters to create variables. Yeah,
So in case like a part of your program changes later, you just go back to that little piece of it and then
Yeah.
the variables.
Yeah, right. So the purpose is it allows you to create a function that mostly does the same thing, but maybe has little bits of it that can do that will behave differently depending on how you're using it. So like, as an example, we had greet person. Maybe we want to greet different people, but we want to add other stuff around this. Like we want to do, this is, an amazing greeting machine. But we don't want to greet the same person every time. We want to actually have some variety to it. Then you can use keyword arguments and, just arguments in general to make it work a little bit differently every time. So like, as an example with addition and subtraction, we don't want to subtract and divide the same number every single time. That would be really sad. We want to change which ones we're using every time. Hence, we have parameters to do so. Any questions before we go into return statements? These are the next big piece of the puzzle. Okay, let's go on to return statements. So return statements allow data to escape the function. It allows you to, so far, all of our functions, everything that is defined or happens in that function stays in the function. It's a little bit like Vegas or something, I guess. Whatever happens in that function stays in that function. It's not going to leave. It's not going to exit. But what a return does is it'll actually let a variable escape. It'll let the value of a variable, really specifically the value of a variable, escape the function, leave the function, or return from the function. And this is so here we have ask for name is a function we define. And does anyone want to help walk through this function for me verbally? Yeah. Okay.
So first, we define a function.
Yep.
Define ask for a name.
Mm-hmm.
And then we call a function, we print hi here.
Yep.
And then there's another input asking for the name.
Yep. And then the name goes inside the name variable.
And then you return the name.
Then you return the name variable. Yep. And that point, here's the way to think of it. When you're calling the function, yeah, that was really great. Thank you. When you're calling the function, whatever is after the return statement, remember how I was saying things resolve? When we do something like a equals 10, and then we do a equals a plus 1, this a goes inside of 10, and then what happens to a here? It resolves into 10, and then what's 10 plus 1? That resolves into 11, and now 11 goes into A. That's the idea of resolving, values resolving. When a function invocation resolves to what comes after the word return in that function. So to go over that again, it asks for name, it then takes a name, puts it inside of the name variable, then we do return name. Whatever's inside of the name variable will then get replaced with here. So this is like their name equals name. It just made that variable name escape the function, or really the value in that variable escape. So let's say we run this, I type in, for my name, I type in Michael. Typoed exactly like that. Then this is a string, so then it'll be the same as just return Michael. I'm gonna fix this. So then it's the same as return Michael, and then this string replaces the invocation over here. So it trickles all the way down back to where it was invoked. And then what happens to this? The thing on the right goes in the thing on the left. So then Michael goes into the variable their name. So this will actually ask for a name and then put the value of the return into the their name variable. Return lets data escape a function, and then when the function invocation is replaced with whatever the value that comes after the return is, whatever value comes after the return. Questions about this? This is an important concept in functions. Yes, Alex?
So the return always has to be the last thing before you invoke the function.
Great question. So the return is often the last thing in a function, but not always. So the return has another use. So the primary use is lets data escape the function and report back with results. There's a secondary use of return that just exits the function prematurely. So if you ever want to just bail out of a function prematurely, you can use return to do so. Here's an example like car owner survey. Own a car? Yes or no? If they answer no, like that, I don't even want to go even further with this. So we use return to exit that function right away. So secondary use of return exits it right away. However, for the primary use of return, Alex asked, is it always the last thing in the function? Yes, pretty much. The primary use is typically the last thing in the function. The secondary use of the return does mean sometimes you put it in like an if statement inside of the function somewhere. So basically the secondary use lets you put it inside you can put that inside of an if statement to make it conditionally exit a function prematurely if you want to. So it's a escape hatch to exit the function. This one can have a value too, like, invalid person or something. Invalid survey. I don't know. You can put out whatever value you want there. Doesn't have to be a variable too. Like, just to be clear, this doesn't have to be a variable. Often it is, but it could also just be like 10, or it could be any value on there, like, anything you want could go after the return. Yeah, Roman.
So basically, does it mean that once you run the function, as for name is equal the name after return?
Mm-hmm. Yeah. So after you run this function, and we can actually we can actually run this function too if you want to actually see it happen. So I'm just going to delete the rest. Which one's this? Return demo. So hi there, name, and we can do print. So let me start this again. Oh, fuck. I destroyed it. I destroyed the window. Well, this is sad. I'm going to have to start it up again. That was the terminal that I was running whiteboard in, and I accidentally closed it. And then that closed whiteboard.
Can you open applications from the terminal, like run on that process or something?
Yup, and if you close the terminal, it'll destroy that application. So that's what I did. So let's see, return demo. So hi there, name. We can do like Jane. The value we got back, Jane. So notice that this can be this is their name. We can use any variable name we want here. It doesn't have to be name. Name is internal to that function. It doesn't escape ever. The word name doesn't escape, but the value of name does escape. And the value of name is what the invocation gets replaced with. Or resolves to. Gets replaced with is a more colloquial way of saying resolves to.
And based on what you said before with the second option on how to use the return,
Mm-hmm.
Can we use break instead so that we don't confuse the two return?
Great question. No, you can't. Break only exits loops. It's a similar idea. Break is to loops as return is to functions, is the way you can think of it. So break lets you prematurely exit a loop, like a while loop, or what we'll learn later, a for loop. Return only prematurely exits functions.
And if there is a loop in the return in the function?
Then you could use break there, but that'll only exit the loop, not the function. Return. You can use return in a loop too if that loop isn't a function. One thing you cannot do is use return outside of a function. This will just not even refuse. This will refuse to run. Syntax: return outside of function. It's like, hey, how did you get out of there? So that's that error there. So return only exists in functions. Any other questions? So return statement tells a function to end while outputting a value. Return value is that data that exits the function. That's the value that gets handed back. Return values, you're handing back, passing back the baton with some data in it. Scope, that's what I mentioned is, what stays in what happens in a function stays in a function. So any variable defined in a function stays in that function and never escapes. It stays in that function and never escapes. The only way the data can escape is with the return value. Otherwise, it's stuck in that function. The reason we have that is to make our code neater. If we know we don't have to look inside of other functions, then debugging becomes easier because there's less spots to look for mistakes. Yeah.
Return a variable? Does it return the variable and the value?
Just the value. So it does not return the variable and its value. It only returns what's inside of the variable. So a good way to think of return is if there's a variable here, it empties out that variable, like dumps it out, and then pops out of the function down here. So it empties out there, pops out down in line 12.
So return is often the last line.
Typically, yep. It's often last line. Yeah, Matt.
So return is like the pictures from Vegas that always.
Yeah, there you go. So what happened in Vegas, we don't know, but you got some pictures on your phone. That's the return statement. To complete that analogy of Vegas's tourism department slogan. There you go.
It returns only one value, right?
What's that?
So it returns only one, so
Only one value comes out, yeah. You can only return one value from a function.
Can we return a list?
You could return, true, you could return a list. You could do like all the names equals, you know, Joe, Mo, Curly, and then return all the names like that. Any other questions? So you could return a list, could return a string, could return an integer, or could return a dictionary, anything we've dealt with. Positional arguments are arguments specified by position. Keyword arguments, named arguments specified by the assignment syntax with the equal sign. And scope, the idea that data can't escape a function. Return statements is that tells a function, one, to end, two, to output a value. So that's that secondary usage. You can use it to end functions prematurely. If I typed a return here, this is actually valid, but it'll make my function do nothing. This makes my function end right away without doing a single thing. I put a return statement at the very top, which is why typically you don't do this, right? This is basically a mistake. I don't think there's any situation where you just put a return statement and then have stuff after it. You never want to do that. The only times you ever want to do a return statement to end a function prematurely is if, for example, there's like an if statement. So like if name equals, you know, Michael, then we just do something else. Print, oh hey, return Michael. It corrects it. I don't know. That's an example of how we might use multiple return statements. That's only if there's an if statement because it ends it prematurely. Why don't we actually just get started with activity 4, and then we'll circle back in like 5-10 minutes for the last bit of stuff for today. Yeah, what's up? No, that'll work. The thing that won't work is yeah, that should work. It does. Let's see. Ah. Yeah, that's good. Oh yeah, that does work. That's weird. Let's see.
So it doesn't have its no.
Yeah, I guess that does work. That's weird.
Yeah, that actually makes sense.
It does kind of make sense, but I didn't think that worked.
So it's basic. Okay.
Yeah, yes, it works. Cool. There you go. Learn something new every day. going over challenge 1 in a moment. First thing we want to do is add a print statement.
For a loop on the sum of two squares?
Yes. A squared plus b squared equals c squared.
That's the length of two sides of a rectangle, right?
Yeah, it deserves the length of length of a line. So a line like this, the
Triangle, right?
well, yeah. So it's like if you have
The length of two sides, you can get the third side.
right. So like if right. So it's the length of the line. So like if there's a line at any like a line, if you know the coordinates of the final point,
Got it.
then you take the square, the sum of those two squares. Yeah.
Square root of the sum of the square.
Yeah. So as I was editing, right file. So I'm going to be going over challenge 1 now. This is about fixing various typos and mistakes. So the first one is comma name requires a parenthesis and a colon. This is how we're supposed to do that. The second one is this return should not have a space in it. So we got to get rid of that. The third mistake is we're missing a parenthesis right here. So let's give that a shot. Uh-oh. Do I have more mistakes? Ah, ha ha ha. Another mistake. There's a space instead of an underscore for last name right there. Let's give that another shot. There we go. So what this does is it returns the name flipped around. So William Shakespeare becomes Shakespeare, comma, William. Yeah, what's up?
Okay, so in this example, you didn't have to call the function. The return.
We're calling the function right here. We're invoking it right here.
Return into the variable.
Yeah, so this is what's invoking the function here.
So you just bring
Here we can. Mark, could you grab the door? Mark, thank you. So then, it's an example of, whoops, I copied everything. We don't have to copy that, so we can just we can use it twice like this. I'm just going to work on this a couple more minutes, then I'm going to go over some solutions, and then we'll do the final activity. After that, go over a little bit more content.
Yeah, three that
Yeah, and the other reason it's wrong too is that after return statements will never get there.
yeah, so
After return will never get there.
even though if I put the return underneath it, it's
It'll still be wrong, yeah, because it'll be an infinite loop.
Yeah, I was doing this, like, just doing name, but it's reading. It doesn't provide the content.
Yeah. You could also do like suggested ways to one half power. That'll do the same thing.
And we tried getting it working here and then modify it to do returns. What's that? That works perfect to me. You did it. Just to be here, you can also do it with just positional arguments. So now that'll also work. It's using position. Does that make sense? There's no positional means there's no equal sign.
It just knows because I'm identifying it.
Yeah. Yeah. It matches them up. I'm gonna try to squeeze by case. Whoa, sorry. It's almost I'm just like picturing some random snack that is eating on your controls and just shoulder zips off, never in hands. Would be pretty funny. Yeah. It would not be funny if it hit the projector, but yeah. That would not be funny. I don't know who did. I'm not calling anyone out in particular.
Sherry ratted himself out.
Yeah.
Too late.
Yeah, I didn't know any of that actually, but apparently something happened that I didn't notice that sounds bad. I'm going to be going over solution challenge 2 now. Write a function called prepare greeting. It should combine the string hello followed by a name supplied as a positional argument and return this combination. For example, if we do prepare greeting Joanna, it should return hello Joanna. Write the function's invocation. Assign the return value to a variable. That's not supposed to be a variable twice. Not a variable, just a regular one. Print the value of the variable. So what it's asking for here is we need to write a function called prepare greeting. So def prepare greeting, and it should take a positional argument such as name. Then it should return hello followed by that name. And then to use it, we'd invoke it like prepare greeting Joanna. However, we want to actually put the result of that into a variable. So we can do my greeting equals this, and then we can finally print my greeting down here. So it's kind of like what we're doing actually with kind of like what we're doing up here with the common name, except we're doing it with just a single parameter that then returns just hello, their name. Then we can print it out right here. The value of the return goes inside of my greeting. In the interest of time, I'm just going to skip to the solution of challenge 3. So challenge 3 uses what's called the Pythagorean theorem, which is a thing from geometry to determine the length of a line. It can determine the length of a line based on its coordinates by multiplying them and then getting the square root. So here it's like, you can think of this as if you go like 3 blocks, or like, you go 3 miles in one direction, then turn left and go 5 miles. How far away are you from the origin of where you started? This is what the Pythagorean theorem will calculate. And the purpose of this exercise is to show that you can actually do a little bit of math in your functions, which is something that makes them much more useful. So you can actually, in this example, we multiply x by x and y by y, and then take the square root of that and return the value into the function, into the variable that's outside of it, so we can get calculation. We can store like a formula and reuse that formula as many times as we want. That's the purpose of this example. We're going to go just speed on ahead to the last topic we'll do today, and then have an activity about that, and that'll be all for today. The last topic is going to be strengthening your coding ability with something called methods. So, today's topic is functions. Another word for function is method. Another word for function is method. However, methods are a very specific type of function. So it's not just that all functions are methods. It's just certain functions can also be called methods if you want to use that word. And a lot of people do want to use that word, so you'll see that word a lot. Certain functions are called methods. Object-oriented programming is a way of organizing our functions and data into classes. We're going to be learning about this more next week. So object-oriented programming, we're going to jump into next week more. But the big picture is it's a paradigm, an approach to programming where people have discovered that a lot of their functions all kind of wanted to be categorized together. They wanted to categorize their functions together. Just as I remember, just as earlier, if you remember, I mentioned one of the purposes of functions is to categorize your code, provide labels for your code. So like, as an example, if you have a lot of code and you want it to be clear what the code does, like what blocks of code do what, like I gave the solution to the game as an example. See, like all of this is in the function of bedroom, so there's a lot of code within that. So the function provides clarity when you're reading other people's code that all of this has to do with the function bedroom. All of this has to do with the function bathroom. All of this has to do with the function hallway. So all of this is inside the hallway function. So functions let you categorize your code and like lay it out in a bit more neater of a way. Classes let us then categorize our functions. So that lets us group together functions. Now, so far we've been dealing with functions that are not in classes. They're not grouped together. But we're going to be learning about what a function that is grouped together. When a function is grouped together, we call that function a method. So functions that are inside of a class or attached to data are called a method. Functions that are attached to data or inside of a class are called a method. And class is another way we can also call a data type. So we've talked about different data types. What are the different data types we've talked about? String, integer, float, tuple, list, dictionary. Yeah, these are all data types. You can also call those all classes. That's another thing you can call them all. So dictionary is a class, list is a class, string is a class. These are all classes. So it's almost pretty much synonymous with data type. Those are synonymous terms. Type and class are more or less synonymous. Now, in object-oriented programming, these classes or these data types can have functions attached to them. So the function isn't just loose. It isn't just hanging out by itself, and you can invoke it not paying attention to what class it's attached to. Methods are attached to a particular class. As an example, and I think we've been using functions and methods all along, actually. As an example, let's think about some of the things we've been learning, like print. What does print look like to you? It's got those parentheses. It's a function. Print is a function. Input. What does this look like to you? It's a function. Print and input are both functions written by the Python programmers that we're using. So we've been using tons of functions all this time. We've just been pretty much now defining them. So this is the first time we're actually writing our own. But print and input are all functions, along with there was another one that we used today. to get the length of a list, len, L-E-N, that's also a function. So these are all functions that they're not written by us, they're written by the people who wrote Python. The people who wrote Python wrote a lot of methods also. As an example, I'm just going to do some demo of this. So here we have, I'm going to go ahead and do an example. Let's create a fave things equals, I don't know, capybaras, and what are other good things in the world? Dolphins, lollipops. I don't know how to spell those. Popcorn. Chips? All right. So these are all our fave things. We can then print fave things or whatever. We can do stuff with it. But there's another thing we can do. We can do fave things dot append. That'll add something to that. Append. What's a new fave thing we want to add? Vegemite. Okay. I think that's how you spell it. I don't know. If this were a Australian demo, then certainly that would be one of their favorite things. So we do Vegemite. But then we do print. So I'm going to do that. So I first do print fave things and capybaras, dolphins, lollipops, popcorn, chips, and then capybara. And then when we add Vegemite to it, it actually adds to the end there. When you do append Vegemite, it just gets added to the end right there. So dot append, so we'll see this here, my fave movies, Titanic, Frozen, Shrek. I'm just going to solve this first one, which is a bunch of typos. So my fave movies we started off actually as an empty list. So there's an empty list. Then we use dot append. Look at this dot. That dot is telling that we're dealing with a method, a special type of function that's attached to a type of data. In this case, my fave movies has dot append. Every list has a dot append. That's just what makes it a list. Lists have dot append. And you can always do dot append after a list to add something to an already existing list. This will add a new item to a already existing list. What do you think dot reverse will do? Make the list go the opposite direction. Yeah, so dot reverse will reverse the order of the list. So if we try this out, we see that it prints out Shrek, Frozen, Titanic, because it reverses the order of the list. Instead of Shrek, Frozen, Titanic, instead of Titanic, Frozen, Shrek, it goes Shrek, Frozen, Titanic, reverses the order of the list, and because the appends add to the list, reverse will actually reverse it. And these are all called methods because they start with a dot and they come after some type of data. Questions? So, and the reason we're introducing them is right now isn't that you have to be writing these yet. It's more just like this is what you call them, and there are hundreds of them available. There's so many methods already written that do many things, from reversing, sorting. How do you think you might sort the list alphabetically? Dot sort, right. So dot sort will suddenly be Frozen, Shrek, Titanic, because that's the alphabetical ordering of that list. And then there's many others. For dot remove, if we just want to remove one item from that list, like we want to remove, I don't like, maybe I don't like Frozen anymore. I could do remove Frozen, and then it'll just be Titanic and Shrek. Yeah.
In this context, is my favorite movies the class?
The class is list,
Class.
because class means the same thing as data type.
Got it. So append will work on the class list. My favorite movies happens to be a list.
Correct. If it was a dictionary, let's say my favorite movies is a dictionary with these guys, so we're gonna have some issues. dict object has no attribute append. So because dictionaries don't have append. Append is a method that only works on lists. Dictionaries have other methods. So like, and you know, how do we know what methods and lists, methods and functions we have available? Let's go to Python's official documentation. And then we can go to, so one caveat with Python's official documentation, it is everything. It is the book that defines Python. So sometimes it's more than what you're looking for, but this will have every single method available. So we can go to like library reference. Okay, here's built-in types. So we have int, float, list, dict. These are all the ones that we've learned about. So let's look at just one of these, like dictionary. And then we see class dictionary, a lot of stuff that we can just kind of look over. And then, here's all the options. Clear, copy, get, keys, pop, set default, update. These are all the methods of a dictionary. If we go to list, oh man, list is mentioned a few times here. Also, strings have methods too. So like any of the things we've dealt with so far have methods. So like let's look at lists methods. Scroll down. So here's a bunch of examples of list methods: append, clear, copy, extend, insert, pop, remove, and reverse are a bunch of examples. And then sort, another example of a list method. So there are a lot of methods. Activity 5 we obviously won't have time to do in class, but it's to give you more practice with the different methods built into Python already available for you. So check it out when you have time on your own time to get more practice with Python code. Questions before we close off today? That's activity 5. And also another reason to do activity 5 is it's entirely Shrek themed. So yeah, so that's another reason. Let's see. Yep. All right. If there's no more questions, we can actually finish 1 minute early. Imagine that. What will you do with all this free time? Oh, never mind. No longer a minute early. Okay. See you all on Saturday or tomorrow. Come tomorrow for review session. Get more practice with homework. Get homework in. Ask questions about homework, etc. And yeah, what's up?
So, actually, I went for the EDV for the extended training program.
Okay, for what?
Extended training program for the EDV unemployment department.
Oh, sure, yeah.
So, they said actually.
Do I have to sign something?
Well, you have to actually put up some stuff.
Okay, let's see. We're not official, so to be clear, we're not officially registered with anything.
I know, it's a long shot.
But,
yeah. Not even qualified. So I thought maybe, I had to do these.
Okay.
So they asked you, training for the first year and the training for the
okay,
this document for your
yeah, let's see. Oh my god.
Yeah, it's so many stuff. Believe me, I have 3 pages. I have to do it on my own.
Okay. Yeah, I'll have to look at this to make sure I can fill this out.
Yeah.
Because I obviously want to, legally fill this out if I can.
Yeah. I think I don't